Hi, this is a presentation of different wireless concepts and it's a part of my CCNA3 course. We all use wireless networking today because it's so easy. Whenever I want to attach to a network today, I'll just use my wireless network interface card on my computer or what's built in my phone, for instance, or whatever kind of device I have, and I just attach to it. And it doesn't matter if I'm here at the school or I'm at home or I'm in the airport or wherever I am, I'm typically always able to connect to some kind of wireless network. So it makes it easy for us users to be always attached to a network. We can be, if we have a large wireless network like we have here at the school, we do roam between the different access points. So it doesn't matter when I move inside the school, I'm always connected to an access point. And of course, when we look at the benefits of wireless networking, it's the obvious ones. It makes us more flexible. Maybe it makes us more productive. I don't know. There is also a drawback to always being online. So and it's cheap. It doesn't cost much to set up a wireless network, and it's quite easy to scale it up. So we don't really need to buy a lot of expensive networking devices to make our network scale up. So it's easy and cheap. When we look at the different wireless technologies, we can also look at the range that they operate on. What we are talking about mainly when we look at wireless networks is the wireless LANs, where we use the 802.11 standard. But there is also something called a wireless PAN, a personal area network. For instance, when we are using Bluetooth. And Bluetooth is a wireless technology as well. It's the 802.15 standard that uses Bluetooth. Normally we say a couple of meters, maybe up to 10 meters is the range of Bluetooth, but it might be possible to communicate up to 100 meters. But wireless or Bluetooth is mainly when we are in a short range. Then we have the wireless wide area network that operates within kilometers, I would say. So it's a huge wireless network. We have the normal wireless LANs that operates within a couple of 100 meters, like the one that we have here on the school. Then we have the Wi-Fi, which is a standard for different on how we operate on different VLANs. It provides network access to home and corporate users and includes both data and voice and video traffic, typically up to a range of 300 meters. We also have the WiMAX or the WiMAX, which is another standard that operates on wireless broadband up to 50 kilometers approximately. It's not that much used anymore because now we have the cellular broadbands, which now actually are operating on quite okay bandwidth. So we are normally using the cellular network instead of using WiMAX for broadband connections. And then we have the last one, the satellites, when we are really into large ranges that we will operate on. For instance, when we are looking at oil rigs or ships out in the ocean, for instance, we can use wireless broadbands for that connection. All these wireless technologies, they operate on the radio waves in the radio or in the electromagnetic spectrum. There are different types of wavelengths that they are using, or frequencies, and we will see here that when we look at the 802.11 standard, it mainly operates within 2.4 gigahertz and 5 gigahertz. The newer versions, the AD versions, also operates on the 60 gigahertz band. There are different regulations in different countries of what frequencies that we are allowed to use. here in Denmark, we are allowed to use the 2.4 gigahertz. That is a free spectrum, and I think that is in most countries. We are also allowed to use the 5 gigahertz spectrum in certain under certain regulations. There are some things that, for instance, or some rules, if you are very close to a military airport or other military facilities, then you might not be able to use the 5 gigahertz. But normal companies and not special things might, you are allowed to use the 5 gigahertz. Then we can see also here on the different standards that the oldest one, the original 802.11 had the maximum speed of 2 megabits. And then we have the A for 54 megabit, we have the B for 11 megabit, the G standard on 54, the N on 600 megabits per second, the AC on 1.3 gigabit per second, and the AD on 7 gigabit per second. These are all maximum standards, and it's when you are very close to the access point and all alone on the wireless access point, you will have these maximum speeds. Normally, when we are always when we are operating on a wireless network, we are sharing this speed or this bandwidth with the other users. We will also see here, or you can see that the newer versions of the 802.11 standard is backward compatible with either the B or the A, B, and G standards, and also the N. So they will make them all backward compatible. The Wi-Fi certification is, of course, compatible with the 802.11 standards and also the 802.11i, which describes the encryption and the authentication protocols that we can use on the 802.11 wireless standards. Then there are a standard for, or a setup procedure, there is a sharing procedure, there is how to connect to a hotspot securely, and there is a mirrorcast, which means that we can set up a display or a video between these devices, so I can screencast my the content of my screen, for instance. When we compare the wireless LANs to the normal LANs, we see that, of course, there is this obvious difference that we operate on the radio frequency with the wireless LAN and on cables on normal Ethernet LANs. On the wireless, we are using collision avoidance, whereas on the cables, we are using collision detection. Of course, we are not able to figure out that there has been a collision when we send something out into the air. We need a cable, of course, to connect when we have Ethernet LAN. If I have a wireless network interface card, I can just connect to any wireless network, of course, unless there is some security setup. There is a lot of signal interference when we are looking at wireless LANs. Compared to Ethernet LANs, where we have a cable, it's not much interference that we experience on a cable. But here on the wireless, since everything is sent out into the air, there are a lot of things to interfere with the signal. And then we have the thing with the regulations. There are different regulations in different countries about sending out things into the air, whereas on the LANs, we only have the IEEE standards that dictates that. There are different sizes and everything when we are looking at wireless LANs. The very simple thing is to set it up in your home. We typically have a wireless home router, and it's typically an access point and also a switch and also a router built into one device. And you're using that typically to connect to your internet service provider to get internet access. When we are looking at in the business solution, well then of course we have these wireless access points typically, which is like a switch or a hub but for wireless connection, and the clients will then connect to these access points. Typically, it's also connected to some kind of a wired network, for instance, to a switch. We can either have autonomous APs that they all are configured independently, or we can have a controller-based AP. But we have a wireless controller that controls our access points. Of course, if I have a huge setup where you have a lot of access points, that is the easy way of doing it. So if we have a small network with only a couple of access points, well then we will normally set them up individually. And if I need another one, I'll just have to configure it, and I do it manually, and I set up all the things manually. But of course, if I have multiple access points, it could be a problem if I need to do it manually with all of them. So then many of our the middle range access points support clustering, which means that they can actually communicate together and then be set up according to how their neighbors are set up, and make sure that they don't interfere with each other. Because of course interference can also happen between the access points if they are operating on the same channel and wavelength. Then if we have a really large setup, well then we have a controller based setup where we have a wireless controller. And this is a Cisco course. Cisco have, of course, different types of wireless controllers. For instance, the Meraki cloud controller. Yeah, and we have different access points that support them as well. We also have, of course, access point for outdoor communication, because if you have a huge setup, I might want to be able to communicate outdoors as well. We also need to take into consideration about the antennas, because normally if you don't do anything, you have an omnidirectional antenna, which means like it's a circle or a sphere around you, like a ball. So it goes out to all directions. It's also called a rubber duck design, because it's the same thing as on walkie-talkies. But you can also buy a directional antenna, which only points out to a certain direction. And then we can have something called the Yagi antenna, which is an antenna that are used for long distance Wi-Fi networking. It's typically if you want to recharge your signal over a larger area, for instance, larger distance. But it is of course important that you keep your signals within your building. You don't want outsiders to be able to connect to your wireless network, and then you can point it in the correct direction. When we set up the wireless technology, we can either do it very simple with two wireless devices communicating with each other without any access point or wireless router. It's called the ad hoc mode. The infrastructure mode, where we have the access points or the wireless router. We have something called tethering, where we have a personal hotspot. This is typically when you use your phone or your iPad or whatever you have as to create a personal hotspot. Then we have something called the basic service set, where we have normally just one access point, and we have the extended service set, where we have multiple access points, and they can work together, of course, with the same SSID. But we will see more to that later on in this chapter. Yeah, that was it. Thank you very much.